Hello everyone, welcome back to our metallurgy part 2 for class 10 cbse. In the last video, we have started talking about extraction of metals for cbse 10 and we have discussed part 1 which contained this discussion about metal reactivity series and also followed by some terminology. And in today's class we are going to continue the same topic and I'm going to explain you the entire process of extraction of metals with the help of a flowchart. This flowchart which I'm using right now is slightly different from what is there in NCERT, so maybe you would have to make a note of it. Well, the entire metallurgy can be put together into 4 steps, of which the very first step is concentration of metal. So what is this concentration of metal? Let us make it more clear. So in this concentration of metal, we remove impurities, but before that, let me just tell you, the ore that you are obtaining from earth crust will be consisting of a lot of impurities, right? So before you talk about this ore and extraction of your metal from this ore, you should think of removing these all unwanted impurities. So the removal process of these unwanted impurities is called as the first step, which is concentration of ore. Yeah. So the first step is concentration. In some books you also get to see it as enrichment of ore, right? And once this enrichment of ore is done, we'll go to second step. But before that, let me also tell you what happens in this ore enrichment. Your duty is to remove impurities with the help of this first step, right? But then how do you remove impurities? For that you would have to observe the nature of impurities and the metallic ore. If you are talking about sulfur containing ore, you have to use a process called as froth flotation. You absolutely no need to know what happens in froth flotation. It's completely out of your syllabus, but it's important to know the name froth flotation, which is suitable for sulfur containing ores concentration. Otherwise, if you're having the ore which contains iron and compounds of iron, you can use magnetic separation. Otherwise, you can also use gravity separation in order to remove impurities. I repeat, you don't need to know what is happening inside this method. Just know the name, that is enough, right? And once you are done one among these 3 methods based on the nature of ore and nature of impurity, then you would have removed all these impurities and you would have had only metallic ore with you. And now you have to go to the second step. And what happens in the second step? You have the ore which is concentrated, which doesn't have any impurities. And you have to now convert that ore which is concentrated into its oxide form. But why into oxide form? Why not directly into metal? See, the type of ores that we usually have are carbonate ores, bicarbonate ores, we have sulfur containing ores, we have halide ores, etc, etc. So removing this all carbonates, bicarbonates, sulfur, halides cannot happen in one step because they have a strong bond with the metal. So it has to happen in stepwise manner. So that is why we first decompose this metallic ore, let it be carbonate, bicarbonate, sulfide or whatever, we first decompose into its oxide. This is the first step. And then we still decompose this oxide into its metallic form, right? So the first step is turning ore into its oxide form. But how does that happen? Let us see. How does this happen? Turning the metallic ore into its oxide form happens based on the nature of this ore. Say you are having carbonate CO3 minus 2 or bicarbonate or HCO3 minus. Then you have to heat it. Heat it very strongly. In absence of air or oxygen. That's when you can convert this carbonate or bicarbonate ore into its oxide form. And you call this process as calcination. Isn't it familiar? We spoke about in part 1 as well, correct? And now if you are having sulfur containing ore, then also you have to heat it strongly only. Very strong heating. Heat strongly, but then remember this has to happen in excess of oxygen. The major difference between calcination and this method is oxygen availability, and you call this method as roasting. The byproduct in this calcination is CO2. You will have CO2 evolved, but coming to roasting, you will have SO2 evolved. So this differentiation between calcination and roasting has been asked many times in the board examinations. So it's of course important that you have a good idea about this. Since anyways we are talking about the differentiation between calcination and roasting, let me also write the equation. Yeah, I'm writing calcination here. Just observe. Calcination is strong heating of carbonate bicarbonate ores. So I'm taking calcium carbonate here and I'm strongly heating it. In what? In absence of oxygen. Or you can also write it as in limited oxygen. Limited oxygen or absence of oxygen leads to formation of, look at this, metallic oxide. The step itself is about converting ore into metallic oxide, isn't it? Along with that, CO2 is released. Done. And if it is roasting, I'm writing the equation here. When you talk about roasting, you're talking about sulfur containing ores and excess of oxygen. I'm writing a skeletal equation, but you ensure to write balanced equations in the exam, right? Now, zinc oxide plus what else is the byproduct? SO2. Done. So these are the equations for calcination and roasting. And calcination or roasting stands as the second step. Let us quickly go back and have a quick summary. We are talking about the steps involved in the entire metallurgy or extraction of metal from its ore. The first step stands to be concentration, which is nothing but removal of impurities. And this removal of impurities can happen in different ways based on the nature of ore. Froth flotation for sulfur containing ores, magnetic separation for iron containing ores, and for rest of them gravity separation. And then after separating impurities, we have to take this concentrated ore and turn it into its oxide form. It's simple oxide form. And that happens again based on the nature of the ore. For carbonates and bicarbonates, calcination. For sulfur containing, it is roasting. What if it is some other ore? If it is some other ore, we have different other methods that are not there in our syllabus, so I'm not talking about all of them. Done. Now let's go to third step. We are done with second step. We are now moving on to step 3. I'm listing step 3 also here. You are now having this oxide ore. You have to convert this oxide ore into its metal form. That means you have to remove oxygen, and removal of oxygen is literally called as reduction. So this step is nothing but reduction. But then how can this reduction happen? Again, based on the nature of metallic oxide that you have. Say, the reduction step 3, reduction is happening. First, you have to observe the nature of metal. If you are having a very reactive metal, okay, then that means the metal would have been strongly bound with that oxygen. That means you would have to use a lot of energy to break the bond between metal and oxygen here. You use electricity, and you call this method as electroreduction. Electricity is one of the most powerful energy supply that we can give to break the bonds. If you are having the metal which is moderately reactive, moderate, then you would not need so much of energy, or you don't need so much of electricity or so much of power. Then what do? You can simply use a reducing agent. Reducing agent is what? Note down the definition of reducing agent if needed. Reducing agent is something which can absorb oxygen, which can take oxygen from the other molecules. It takes oxygen from other molecules. Okay. Now, if you are talking about the metals which are least reactive, like mercury and all, you can simply heat them. Heating will remove oxygen. Yeah. And one more thing, examples of reducing agents that we commonly use: carbon monoxide, hydrogen. So I'm talking about third step in extraction of metals, which is reduction. So in this third step reduction, you have to look at the nature of metal that you have and choose how to reduce it. If you are having this method, if you are having this particular metal which is more reactive, then you have to go with electroreduction. Moderately reactive, you have to go with reducing agent, and least reactive, you have to go with reduction with the help of heat. We'll talk about these equations in the next page, but before that, please ensure you are not confused with the steps that we are talking, and please make sure you are having a quick notes written down. Yeah. Now, let's go to the next page and let's talk about Some examples of metals which undergo reduction with the help of electricity, with the help of heat, and with the help of reducing agent. Okay, so to begin with, the first one, with the help of electricity, we call it as electro-refining, correct? Let me not use this symbol, it confuses you now. So yeah, electro-refining, especially elements such as aluminium, potassium, sodium, oxides of them are reduced. Guys, one second, it's not electro-refining, it is electro-reduction. Electro-refining is entirely different from electro-reduction. I'm so sorry for this. Yes, it's electro-reduction or electrolytic reduction. Now, yeah, I'm taking example of aluminium. Say I have aluminium oxide. When I strongly heat it in presence of electricity, it leads to formation of aluminium plus oxygen. It's a skeletal equation and you got to balance it. And now the second one, reduction with the help of reducing agents. Reduction with the help of reducing agents. How does this happen? This happens when you are having a moderately reactive metal such as zinc or copper. So I'm taking example of zinc. Say you have zinc oxide and use a reducing agent like carbon. Gives you zinc plus carbon monoxide. Yeah, did you see what happened over here? Zinc has lost oxygen because carbon is used. Carbon here acts as the reducing agent. Okay. Now, moving on. Third step. Third step is nothing but using heat to remove oxygen. Least reactive metals such as mercury on heating will decompose into mercury and oxygen. Remember these three examples which are important. They might ask you to write the equations of different sorts of reduction in exam. So let's go back and see what are we doing. We were talking about different steps in extraction of metals, of which first one is concentration, second one conversion of concentrated ore to oxide form, third one converting oxide into metal, right? Now let's talk about the fourth step. The fourth step in fact is called as purification. Okay, and this is often regarded as refining of metal. If you have clearly noticed in the previous step, out of reduction you have already acquired your metal, right? Let you deal with any type of reduction, but you have acquired your metal already, right? But then what is this fourth one? The fourth one is refining the metal that's acquired, because you have let the metal process through the concentration, conversion into oxide, and then reduction. There is possibility of some impurities or traces being left behind, and hence we call it as we take refining of a metal as fourth step to remove all those traces, all other reagents or impurities if any left. There are different methods of refining metal, but prominent one that we use is electro-refining. Yeah, previously we used a term called as electro-reduction, which is different from electro-refining. Electro-refining of copper is in your syllabus. This is very important. Probably in part 3 we'll talk about electro-refining of followed by aluminium is electro-refined, and also sodium, potassium are electro-refined. And out of electro-refining we get 99% pure form of the metal, so it's used to a greater extent. But other than electro-refining, we can also use chromatography to refine metals. Chromatography. Otherwise we can also use a method called as zone refining. But absolutely this is not in your syllabus. Just be aware of the names. Yeah. Now we discussed about 4 steps of extraction of metals and purification. Let's try to list all of them in the same page so that we have a better idea. Okay. Step 1. Step 1 is concentration. We'll do something. Let's write it from the corner so that we can accommodate almost everything in the same page. Step 1 is what? Concentration of ore. Followed by second step. What is second step? Second step is nothing but conversion of that concentrated ore into its oxide form. And third step, conversion of this oxide into its metallic form or into its metal. Fourth one, refining the acquired metal. Yeah, now did you get an idea? Yes? Good. I hope everyone's able to follow. You also can pause the video in between and replay if you have missed the flow somewhere. Now, let's go back. Concentration of ore can happen in different ways. One is froth flotation. Second one is using magnetic separation. And third one is using gravity separation. Because gravity separation is nothing but separation with the help of density. Based on density we separate. And after that, once you are converting your metallic ore into oxide form, you can do with the help of roasting, or you can also do it with the help of calcination. And you know about them in detail already. Do you? Very good. And now the next one, converting this oxide ore into the respective metal. This is also called as reduction. And this reduction can happen in three ways based on the type of metal that you have. Reduction with the help of electricity for more reactive metals, reduction with the help of reducing agent for moderate metals, reduction with the help of heating for less reactive metals. And once this reduction is done, you will get a metal and you have to refine that for more purity. Different ways of refining. Most important is electro refining, which is different from this electro reduction. Electro refining and electro reduction are different. Then could be zone refining, could be chromatography. Correct, guys? I hope you're all clear about these steps. This flowchart is slightly different from what is there in NCERT. Now, in this video of part 2 metallurgy, you have understood how the steps go around. And we'll also have one more video, part 3 of metallurgy, where I'll explain you the electro refining of copper, which is important. And often they might also ask you to draw the diagram and label it. It comes for either 2 marks or as a part of 5 marker question. Done? Now, let us wind up for today, and I'll see you all in part 3 of metallurgy. Bye everyone. And of course, please let me know in the comment section if you need more such videos or you have any more questions. I'll see you all. Bye bye.